Okay, let's kick off. My name's Ante. I'm a data scientist at Arden and Gem, CSU, and today I'll be speaking to you about social prescribing with a machine learning perspective. Okay, formalities aside, I'm just going to like ad-lib this. So basically, I want everyone here to benefit from understanding this talk. This is about data science. I know people's perception of data science is like, oh, who really understands it? I mean, can people raise their hands, those who feel like they know about data science or are expert in data science? One. Don't be shy. Okay. I'm just going to aim it in the right way because we'll go into detail, but I want everyone to walk away from this talk benefiting in some way. Okay. Okay, I want you to participate as well. So if you could all, those who are able, stand for me. And if you could fold your arms for me. And if you notice, if you ever have noticed, how you actually fold your arms is one like folded under the other. And if you think about the healthcare that we receive, is it according to your need? Is it according to the way you fold your arms? Is it according to exactly what each individual needs? Thank you so much for participating. You can sit down. Okay, so what is social prescribing? So first of all, it's a program that has been set up to engage patients from primary care into interventions which will help them in terms of their mental, physical capacity in a holistic way. Critically, it doesn't involve medical care. So these can range from things from gardening, cooking, any activity that doesn't involve a pharmaceutical element. Not that I'm anti-pharmaceutical in any way, shape or form, but in terms of social prescribing as well, the way it works is that the social prescriber works through the clinician. The clinician would look at the patient record and refer to the link worker as well. The link worker is the intermediary, would connect them to the social prescribing service, the services that I've mentioned, which have almost like an infinite list. In terms of social prescribing from a national perspective, it is on the nation's mind. NHS England in 2020, they actually recruited nearly 1,000 new social prescribing link workers. And by the end of this financial year, you will actually see at least 2.5 million people who have accessed social prescribing in some way, shape, or form. So I don't think you need to be that great at doing statistics to know that it's a trend that will be growing, considering we cannot keep on this trajectory in dealing with long-term health conditions using medications alone. Okay, should I do this? Can you close your eyes for me? Don't worry, I'm not going to do anything to you. Don't worry about that, okay? Although, who has actually heard of social prescribing or experienced things? You can close your eyes. You don't have to open your eyes when you do it as well. So just can understand, oh, okay, that's quite good. Wow. I would think that's more than the proportion that I expected. But yes, let's launch into the particular context of our case study. So we looked at the population of Bedfordshire, Luton, and Milton Keynes, which has a population of around 1.1 million people. So in terms of its ethnicity breakdown, they're predominantly, there's a larger Asian and other white ethnicity breakup, and the non-whites actually make up around 70%. So if you think about how representative they are for a typical ICV, they probably aren't representative. So we'll just have that in mind. And in terms of those who refer to social prescribing, between the years of 2018 and 2023, there are approximately 20,000 of them, and most of them were non-white, which is not surprising given the actual original demographic. And approximately a third of them were referred to social prescribing from the lowest three tiers, IMD-wise, which is slightly above what you would expect given the above statistic there. So first of all, I'll just kind of summarize what our aims were in this. So we wanted to identify patients who would benefit from social prescribing referrals. So I'll make that really clear that it was just for this purpose. It was engineered with the idea to increase the uptake of social prescribing for the clinicians who were referring and the social prescribing link workers who were referring. And it would also, in addition, help the ICB to understand their particular referral patterns. So this is our particular methodology that we used. We ingested the whole BLNK population information, which, as you know, is 1.1 million people. We had these 3 KPIs in mind to assess the entire program, which were a patient being referred to social prescribing, a patient who rejected social prescribing, and also how many encounters they had with the link worker as well. And all this funneled its way into what I'm going to show you, which is the case finding tool, which is powered by machine learning. It gets just to convey what the purpose is of this particular dashboard, the clinicians and the social prescribing link workers, they were the ones who would use this dashboard, and it would help also ICBs and PCNs to benchmark and prepare to strategic plan as well, and with the potential improvement to patient outcomes overall. Okay, so some of you does anyone know how data science actually works from beginning to end? You can put your hands up so I can just kind of convey the level of detail necessary for this slide. Okay. So yes, I'll go easy. So to begin with, it always starts with the people, the patients, and ends with the patients. So the business needs to be understood. So we talk to the client, we engage them what their priorities are, we understand their assets, data assets, and also assets in the community. And then we start to think about what kind of study design, moving on to the second step, how we can begin to provide a solution for their problem. After that, we've been given access to their data. We would extract the data for certain fields, having done checks on the data as well, data quality checks. And then after that, we would begin to choose a few models that could be appropriate for our research question. So that's the model development phase. And then after that, we go into the validation phase, which is where we train the model on the data. But before that, we have to split the data up into training and test data. And this is done randomly. So it's not a biased thing. It's a computer that just runs the algorithm and does this process, but it's trained on the training data, the model, and then it's also run again on the test data, and then you will see a correspondence. If there is a good fit, you should see a very similar score, which ideally should have a good predictive accuracy. Just have like a laser. It doesn't. Okay. So in terms of looking at model monitoring, this is really important in terms of the longevity of the model. So as we imagine across time, things will change and new data will perhaps invalidate the model. So we always have to be checking that the model isn't biased, the one that was developed originally. So that's critical to ensuring that the model is actually up to spec. After that, we go into model deployment, which is a very simple step, which I'll just slide. And then dashboard is where we present it to the clinicians so that they can actually see and actually act on our insights. So just to get a little bit technical, but I'll try and keep it easy. Has everyone heard of logistic regression? Yes, okay. So it's just a very simple algorithm. These were the 3 that we used in our study, and logistic regression is a very simple model that leads to the prediction of the likelihoods given a binary outcome. For random forests, that's a slightly more complicated algorithm that's based on decision trees. I won't explain exactly what that is, but essentially it's decision tree, each time it does something, it's quite biased, and so in terms of the random forest, it takes a random subset of all the dependent variables, so basically the variables that you're not measuring, and it just does many of them, and then what you see at the right at the bottom is that's the summation and the kind of aggregation of them all, and it's actually very, very powerful. XGBoost is very similar, it just doesn't work in parallel, but it's there to like reduce the particular like loss function of, and it does it iteratively until the loss function doesn't change, which basically means it's optimized. So, technical things aside, I will pass you on to my very capable colleague, Farah.
As my colleague said, my name is Farah, and I will take on the latter half of this presentation. So in terms of what we did for our machine learning process is we followed 3 steps. So our first step, which is the important one, is collecting the data, and you need quality data in order to provide a quality result with your machine learning. So we've collaborated with clinicians to get a list of SNOMED code relevant for the types of events that the clinicians and the social prescriber link worker want to see being used on the dashboard. Once we've had a full clinically approved list of code, we extracted our patient and event level data, and we've extracted data using linked data set, both on the primary care data set and secondary care data, A&E data, community care, inpatient admission data, hospital data. So we put together as much data and the event level data that we needed in order to work on our machine learning algorithm. And our second step, the modeling, as my colleague Anne was talking about, we use 3 algorithms: logistic regression, random forest, and XGBoost. And the algorithm that provided us with the best result was XGBoost, and we tested it using area under the curve RC, which gave us a score of 0.9 for XGBoost. So we selected that model. But then we've added an extra step. We have a machine learning that we've added to our dashboard, but we also added what we call a clinical weighted score. So we provided documentation to multiple social prescribers, and we've asked them to score a series of features to let us know which feature are most important to them when it comes to referring a patient to social prescribing. So they scored it from most important to least important. And from that score, we were able to get a clinical weighted score so that the social prescriber can use both a clinically verified score, but also use machine learning score to select the patient. So now I'm gonna go into each one of those 3 steps into more detail. The data step was the one that took us the longest in terms of collecting the code link and extracting the relevant data that we needed for this project. And once we collected the data, we had to clean it up. So for machine learning, we needed to transform our categorical data into numerical data, and we use one-hot encoding for this. So for example, gender, you've got male, female, indeterminate, and null if we don't have the gender. So putting it through one-hot encoding, it gives a number to each one of those elements, turning it into numerical data. And then we looked at feature selections. So once we've transformed our data, all of our category data transformed into numerical data, we ended up with 134 features, which is quite a lot to run through our machine learning algorithm. So we use feature selection to reduce those features down. The first step that we did was use BorutoPy. In BorutoPy, it duplicates the data set, and then it calculates how important each feature are to determining the output feature, which is would the patient be referred to social prescribing. And from that, we went from 134 features to 52 features. And another feature selection that we're using is PCA, which is a dimensionality reduction algorithm. principal component analysis, and it allowed us to look at the whole data set and reduce it to the most important feature, which reduced our data set to 5 features, 5 elements. And our next step was, once we've got the data set, once we've run the machine learning algorithm, we need to test it. And our test using area under the curve showed us that logistic regression was the best model that we had. And area under the curve, to quickly explain it, it looks at usual positive. So it looks at patients who have been prescribed social prescribing, and the algorithm correctly predicted that they were prescribed social prescribing, and it compares that to the false positive, which are patients who were not referred to social prescribing, but the algorithm incorrectly predicts that they were referred to social prescribing. So it compares those two values to give you this graphic, but also give us the result of 0.9, which out of our algorithm was the best one. And moving on to the clinical, to the scores. So, moving on to the scores, we've got clinical rated scores. So those were verified by the clinicians, and they can use it to compare it to the machine learning scores. And our scores are between 0 and 100. And we also colored it within the dashboard from green to amber to red. And red patient would be the one most likely to be referred to social prescribing. But we also made the machine learning score look different to the clinical weighted score, so that clinician can easily see visually which one is which, and they don't confuse the two. And our scoring system was included into the case selector, into a case finding tool. And with the case finding tool, they can use filters to create the patient cohort list. So at the top of the case selector, we've got our demographic filters. So the gender, the locality, the GP practices, ICD that they're in, and then on the side, you've got further filter. Those are healthcare related filters. So those are filters related to social prescribing elements that they want to have a look at. So for example, we've got the number of long-term conditions that the patient has, but we also got the machine learning score that they can use to select the patient, or number of any appointments within a 12-month period. And with that, they can create a patient cohort list that they can actually export out of the dashboard. But they can also re-identify the patient, and with the re-identification, they can get a patient view with more detailed view for each individual patient. And one of the patient view is a theograph. Raise of hand if anyone knows who created theograph. Yeah, exactly. How cool is that, having a graph called after yourself? So this was created by Theo Giorgio and his colleagues at the Nuffield Trust about 10 years ago. And basically what Theograph does is it gives you a single visual of looking at patient history, clinical history. So you can have the different type of events like any appointments, GP appointments. You could add mental health appointments as well. Any type of clinical point of contact that a patient has, you can add it here, and it shows you the history of that patient having all of those contacts, depending on how long your data, how big your data set is. But what's interesting for social prescribing is that we have social referral added to it, so the clinician can see when the patient has been referred to social prescribing, those interaction with clinician changes over time. Do they have less AV appointments, less GP appointments? They can see that with a single visual. So that's quite a powerful graphic to add to the dashboard. And on to finish up, so further developments for our dashboard, we will be adding red by 1,000 to all of the charts, but the interesting bit within the machine learning side is we want to have a look at seeing if we can improve our AUC ROC score by adding further feature selection to our data set to see if we can even improve the score even better. And one of the things as well is data imbalance. So It's been mentioned twice by my colleague. Does anybody remember how many patients are in BLM care? It's been said twice earlier.
That's my fault.
1.1 million.
Yes, good memory at the back there. It was 1.1 million, but social prescribing referrals, we've only had slightly over 22,000 patients referred to social prescribing. So not a lot of patients were referred to social prescribing. So one thing that we can look at is algorithm for data imbalance. And one that we've used in the past to one of our other projects was SMOD, synthetic minority oversampling, and we could use that to try to deal with the data imbalance, and maybe we'll get a better score. And finishing up to say that we are doing a few talks today and tomorrow. So the first talk has already happened, but all of the other talks are tomorrow from some of my colleagues. So if you want to see us, come and see us to our various talks, and come and speak to us in room CM09, where we will be today and tomorrow. So do we have time for questions?
Yay.
We have a little bit less than 5 minutes for questions. So there you go. You caught my passes.
Thanks very much. That was a really interesting talk. I may have misunderstood this, but the impression I got was the machine learning algorithm creates referral to social prescriber.
Yes.
Now the issue I have with that is you're predicting something that's going to happen anyway. And actually, so I would argue the outcome is incorrect. So what you should be doing is predicting who should be referred. Because what you don't know is if the people who are referred are actually the people who need to be referred, or if there is an imbalance between, there might be biases in the way, in reality, how clinicians refer patients for social prescribing. So there's a risk that the algorithm might exaggerate biases that are already there. So have you actually kind of done a model to look at, how it varies, the rates of social prescribing referrals, how they vary by, different demographic groups?
Yeah, I can do that.
My question.
Yeah, I think I understand your question. So what the initial ask was from BLMK was that they wanted us to, so referrals were being given out, but they weren't sure who to give them to. So we had like historical data where we saw like people who did take them off, what kind of characteristics would they have. So what they wanted was to raise the level of their referrals, but it wasn't obvious just from eyeballing the data. It wasn't obvious how that was happening. So our ask was to enhance those referrals. So referrals can be rejected as well, and those were other metrics that we also based success on. So it's in that way that we weren't, in terms of demography and that breakdown, machine learning has a capability of, how do I say, accounting for all of those things all at once, because of the power of random forest and XGBoost. If you run with too many estimators, then it can overfit. But the ideal is to fit a chord so that it can receive new data. So that's the whole point of doing model management, model monitoring. So that's something that we need to see into the future, whether it does apply to the changing demography. But that remains to be seen. I can't really say at the moment. That's something that will evolve with time naturally. So I don't know if that does answer your question.
Don't let me give you a follow-up. Let me bring more people in, so then you can contribute.
We can continue talking.
Yeah.
Well.
Did anyone else have a question that they wanted to ask you?
Mine was pretty similar. I just didn't understand why. I understood like the dashboard was really useful, the graph and stuff, but I didn't understand why you were predicting whether someone was referred or not. Is it to reduce the amount of rejections?
It's the acceptance of the code. So rather than there are quite a few reductions for the definition. So it's the acceptance that gives it. But I take the point that it's not just we are still replicating the existing practice, the existing practices. But there is a different use case. But here, what we want to do is the maximum uptake to start with, and then there's a really short stuff starting there, and the shorter big stuff, and so the one captures most. That's really possible. Sorry.
And the other thing I wanted to add as well is social prescribers have a paper form at the moment that they're using to fill up to see if they're going to refer a patient, if they're going to take on that patient, refer them to social prescribing and see the patient. What the dashboard does is now, instead of being paper-based, they can have that system on an online system that they have access to. At the moment, it's on a product called Jemima, but it's being transferred to a new product called Athena, and we have a poster presentation outside about that. But basically, it's taking the paper-based referral to an online system, and instead of referring patient, doing one patient at a time, they get the whole cohort list in one time, and on the product, they can actually export that list out, so they can actually print out the whole patient list for the day, the week, if they want to as well. So that's one of the elements of why they wanted a dashboard as well. They wanted to have that element of being able to create a patient list quickly and have that easily available to social prescribers.